Hello and welcome to this course on data visualization with Matplotlib. My name is Valentine and I'll be your instructor for this course. In this course, we're going to use the following agenda to go through the entire learning experience. So we're going to start off learning more about the learning outcomes or the objectives of the course, so that by the end, we have an idea of the extent to which we will have achieved those objectives. Then we'll go through an overview section that entails learning about what the key concepts pertaining to performing data visualization with Matplotlib entail. We will learn why we use Matplotlib, as well as when we need to use Matplotlib. Right after that, we'll go through another section that involves going through a reading and a quiz. So the idea during this particular point in time is to actually go in depth with the concepts that will have been introduced during the overview section. So we'll do that by going through the following reading, which should take you about 10 to 15 minutes. So this reading has just more information about some of the key concepts that we will have covered during the overview section. And once you have finished going through this particular reading, you'll go through a quiz that will assess your understanding of those concepts. Then right after finishing working on that particular quiz, we will go through now practice work, which will entail going through some curated notebook that we have prepared. And this notebook has the different concepts pertaining to Matplotlib, their examples, as well as challenges that you can be able to undertake that will actually help you to practice those concepts and be able to apply them in a real world scenario with just different sorts of data sets. So the idea is that in this particular section, you'll get hands-on practice with the core concepts when it comes to creating visualizations with Matplotlib. Once we are done through this section, by the way, we will also provide sample solutions to the challenges that you will get. That way you have an idea of whether you had actually gotten the solution to what we were what you actually be going through. Once we have gone through the practice work, the next step will be to go through a project, which again we have also curated, that will give you a scenario, a real world scenario where you can showcase the concepts that you will have learned. And we will have provided some guiding notebook that will take you through step by step on your journey when it comes to applying concepts in relation to Matplotlib. So there will be code that already will be populated that will assist you in the entire process for creating Matplotlib visualizations. And you will get hints all along. Towards the very end, once you have worked on now the solution to the project, you can then later verify the solution that you had created with for the project with now a solution notebook that we will have provided. So generally, that is the approach that we're going to be using. So the idea is that after this learning experience, you should be good to go when it comes to working with Matplotlib, and you should also be in a position where you can be able to interpret code in relation to Matplotlib, considering that Matplotlib is a library, it's a tool in Python that allows you to create the most basic data visualizations that you might want to create. Right, so I can't express my happiness on taking this journey with you. So let's get started. So starting us off, what we are going to be going through as the first thing that we'll undertake is just now going through the overview section, which um, will generally, actually, the first thing that we're going to go through is the learning outcomes. So by the end of this particular course, the idea is that you will have achieved these learning outcomes. Recall and describe the fundamental types of plots. These are the basic plots that you might just create in any sort of situation in any project in relation to data analysis or data science. So you should recall and describe the fundamental types of plots, such as line plots, scatter plots, bar charts, and histograms that you can create using Matplotlib. You should also be able to apply Matplotlib concepts to explore and analyze data sets visually, effectively using just different types of plots to identify just data patterns, trends, and outliers. You should also be able to analyze complex data by creating multi-panel figures. So you might decide to create a visualization that contains multiple visualizations. So that's what we mean. So you should be able to analyze complex data by creating multi-panel figures and subplots um, in Matplotlib, and that would help you be able to compare and present data from different just perspectives. So those are the learning outcomes for this particular workshop. So what is Matplotlib, you might be asking? So Matplotlib is a library in Python. So normally when it comes to working with Python code, you might want to, or even just projects in relation to data analysis or data science, you might want to create visualizations. Maybe when you're working on a deliverable that entails visualizing insights, and that you would require that you build, maybe you create maybe a visualization such as a line chart or bar chart. So Matplotlib is a visualization library. So generally what when we say that we are working with a library, it's just generally a collection of code that have been written, that has been collection of code that has been written to perform a specific task. So there could be a library for visualization, and specifically maybe creating static visualizations like Matplotlib. There could be other libraries such as Seaborn. There could be other libraries. Seaborn, you normally use it to create rich statistical visualizations, maybe ones that give you just some more information about the data sets that you're working with. Could be you want to understand the correlation between different or multiple variables, then a library like Seaborn would come in handy. You could also decide to create interactive just visualizations using another library called Plotly, or create dashboards using a library such as Bouquet, that's still in Python, or a library called Dash. So libraries usually a library is just a specific, it's just a collection of code that just does a specific task. In our case, we're going to be learning about Matplotlib, which is the most basic library in Python for performing data visualization. This is usually the starting point of creating visualizations when it comes to Python. And as you will continue in your journey of learning more about Python, you'll get to realize that some of the visualization libraries that you're going to be working with, maybe like Seaborn, would actually be using Matplotlib behind the hood. So behind the scenes, you would still be actually working with Matplotlib. So yeah, so the idea is that you will have grasped some fundamentals by the end of today in order to be able to work with Matplotlib in any sort of scenario. So Matplotlib, therefore, is generally a widely used Python library for creating static, animated, and interactive visualizations. But at the very most, Matplotlib is known for just being able to help you to create static visualizations. It's really the entry point. It plays a vital role in data visualization by providing a set of extensive plotting functions. So a library normally would be organized in what are called, in Python, we call them classes, and those classes usually have methods, which you could think about them as just sections of code within this collection, within this library. So generally, when it comes to Matplotlib, you have those sections which are called methods, but in some contexts, you just call them Python functions. So you have multiple functions that would allow you to be able to create visualization visualizations, basic visualizations, using just simply just Matplotlib. So it provides us with a flexible and extensive set of plotting functions that we can use to create the most basic form of charts. We can also be able to use Matplotlib to with other data visualization libraries to be able to create visualizations that we need. Let's say, for instance, with Seaborn, you can use Matplotlib to be able to even style your charts, to be able to apply some sort of maybe create another visualization within a visualization, etc. There's also extensive customization options when it comes to Matplotlib. So those capabilities are there, and they can help you be able to achieve publication ready visuals. If you have a visualization that you envision, you could even just draw it, maybe using some graphic programming tool, maybe a graphic tool, could be maybe Photoshop, and you wanted to display that visualization, data visualization using some tool, then Matplotlib can actually help you be able to do that by just simply using its functionality and tweaking it a bit. Lastly, when it comes to working with just when you're working on data analysis projects, Matplotlib is usually the most basic form of library if you want to visualize certain aspects of your data. So it really integrates really well with your data flow. So when it comes actually to data exploration, when you're performing just when you're trying to understand the data that you have in order to later perform some analysis. So why do we use Matplotlib? The reason why we use Matplotlib is because, again, initially I mentioned to you, it's usually the most basic form of data visualization when it comes to Python. Additionally, Matplotlib has been in existence since 2003, maybe a few even just months before 2003, as it was being developed. So it's quite stable, and it has been tested across different environments, and it's actually being used today by many organizations to communicate insights in production. So in production, so it means just generally the tools or the visualizations that have used Matplotlib are already already live. So they're being used already to interact with users or clients or whatever organizations might be having, maybe it's customers or clients or etc. So it's well tested. So it's something that's it's a tool that's already proven. It's again widely adopted in the scientific and data analysis communities. So there, if you want to learn more about Matplotlib, or even just have an understanding of an aspect of Matplotlib that you might not have an idea, there's extensive documentation and community support available. And again, lastly, it also integrates really well with other data science and numerical computing libraries such as Python, NumPy, as well as SciPy. Um, when do we use Matplotlib? When should we use Matplotlib? So if you want to maybe embed plots in, or you have some plots in your data analysis work, you could always generally use Matplotlib. If you want to create static dashboards, which are generally just visualizations, like a collection of visualization that communicate one particular thing, then or one or two or three particular insights, then you could decide to use a tool like Matplotlib initially for just creating static dashboards. If you also want to quickly visualize data, you could always do that, again, using Matplotlib, because it's the most basic one. And when it comes to even the code that you're going to be seeing, it's going to be quite simple, or relatively easy to read, as opposed to other libraries, the code for other libraries. So up until that particular point, I would want to highlight the fact that this tool has an extensive documentation. So it's usually just up to you to be able to figure out what best works for you in whatever scenario that you might come across. But it's usually the first to go library when it comes to data visualization. So at this particular point, you can go through now the reading that we have shared, which should take you about 15 minutes. So if you are an after work member, you can just visit the link that will have provided in the section below. Whatever platform that you're watching this course from, you could just click on the link that will take you to now the resources, that the reading itself, and the quiz that will come in after. If you're not an after work member, we don't have you haven't provided resources for this section, but you can download the sample practice work that will come in later, that we'll go through later at this particular point in this particular course. So that will come in after the quiz section has completed. So yeah, so that's it. So there you have it. So you could go through the reading that we had earlier shared, which you can see on your screen. Just go through this reading and then go through this quiz. Then once you have gone through this quiz, after 10 to 15 minutes, then you can come back and we can continue working on the practice work that we have in store for today. So you can pause the video and see you in the next 10 to 15 minutes. All right, so once you have finished and gone through the reading, if you have any questions, feel free to ask in the chat section or the comment section of whatever platform that you're having this course, you're watching this course from, or you're taking this course from, and then we can answer, and you would also find some other persons who might also be able to provide some support. So moving on to the next thing, now we're going to go through the practice work. We have gone already through this power agenda, gone through the reading and quiz section. That we're going to go through the practice work section. So starting us off, the first thing that you need to do once you have accessed the practice resource link, or if you're not an afterwork member, you might see a sample notebook that you can use to just follow along. The first thing that we need to do once you've gotten to this page is to make a copy of this notebook. So you would need to go to File, then Save a Copy in Drive. And this should save, it should save a copy of this notebook, which is just generally a document that data analysts or scientists normally use for their work and be able to share it. So save a copy in Drive. So go to File, then Save a Copy in Drive, and that should open a new link in a new tab. And you can use that copy to make any changes that you want. So do that. Once you have done that, the next thing would be to connect your notebook to Google servers. Normally, notebook like this one that we are using is hosted on Google Drive, and Google provides a service called Google Colab that allows us to be able to work with notebooks within Google Drive, and we can be able to connect those notebooks to Google servers, which will actually run the code that we will have inside. So connect by clicking on the connect button at the far right, which should take maybe 10 to 15 seconds depending on the internet speed that you might be having. And the idea here is that once you're connected, we should now be able to run our code remotely. So from our once we run the code, any code inside our code cells here, we should be able to see an output, and we should be able to also work on the challenges as well. So once it has connected, it should look something like this, as you can see, and we should be ready to go. So I am not making a copy, I'm not saving a copy of this particular notebook because this is not the original copy of the notebook. This is my own notebook that I can be able to make any changes to. So once you have done that, the first thing that we need to do is to install or to import the prerequisites for working with Matplotlib. Just to give you a good understanding, when you're working with Matplotlib, or when you're taking this course, the idea is that you have some fairly good understanding of how to work with Python, and even just be able to perform some data wrangling. One of the things that you will see that we will do in this course is to import some data analysis libraries, or some related libraries that will help us be able to perform some analysis before we visualize data. Those two libraries that will come in handy, one will be called one will be called Pandas, which is a data manipulation library, and the other one will be NumPy. So to start us off, we're going to import Matplotlib as well as Pandas and as well as NumPy. So here, this is how we are able to import Matplotlib. So this line, import matplotlib.pyplot_as_plt. The reason why we are importing matplotlib.pyplot is because we want to use what is called a submodule. Library can be divided in, actually libraries are divided in modules, and inside Matplotlib, this is usually the most core. It's usually the part of Matplotlib that allows us to be able to use the core functionalities of Matplotlib. So we are referencing matplotlib.pyplot in order to be able to later work with Matplotlib functions for plotting just different visualizations. That's what we will do in this first line. And in this second line, we import NumPy. And in this third line, we import Pandas. NumPy it usually allows us to be able to perform scientific computations. Maybe you want to convert integers into floats, then you can use NumPy. If you want to perform some aggregate maybe tasks, maybe perform maybe some min, max, or even do some average, you can use NumPy for that. We also have got some other course on NumPy on that, but you can have a look at that separately. The same case for Pandas. Pandas allows us to perform data manipulation tasks. So we'll import that and we will use it for being able to create summary tables. And these summary tables will just be a summary table. It will just be a table that is basically a summary of a bigger table. And it can come in, such tables can come in handy when we want to create visualizations such as pie charts, bar charts, which generally summarize what actually is happening within a data set. So let's import these libraries by clicking on this icon. Don't worry about this. If you have that pop up, you need to save a copy of your notebook. But for now, I don't want to save mine. So I'll run this and you'll see a check icon on the top left that you'll see there. The next thing that we need to do is now go through first of all, to understand, we now need to first of all understand how to create a basic plot using Matplotlib. And for this particular task, or for this particular, we're going to go through this, we're going to go through two methods, which will allow us to understand the basic structure of creating a data visualization with data visualization with Matplotlib specifically. So we'll go through method one and then later go through a second method. We'll also, while you might see that we are using some dummy data sets, like, we've defined some data, but in real sense, you might get up in the real world, you might get to work with real life data sets which contain hundreds of records. For this case, we're just using just a smaller data set for your learning experience, just to make you understand what is happening, but we'll also provide examples later for each and every concept, like learning about pie charts, bar charts. We'll provide that in some other examples in those other sections. So we'll have an example with a simpler implementation of a data set that we've defined, and also a data set that we can be able to read that will contain hundreds of records in multiple columns. So starting off, just to understand how we can be able to work with Matplotlib, the first thing that we do when we are working with Matplotlib is first of all to by the way, is to define some sort of structure that we want to use in order to create a visualization. So you will see that in our case, we have the first step that we take is to define the data sets that we are going to use. We might do this with the approach that you see here, where we've defined different pieces of data. We might also decide to, even in this section, have imported some data sets and also have performed some data wrangling, and then later onwards prepared data for the visualization. So in any section that you'll see define data sets, just note that that's what we are going to be doing in that section. But for ease of going through the example here, you will see that we have defined what are called lists in Python. These are just containers that would contain related information. So we have an age list, and then we also have a DA salary, data analyst salary list that contains just information about the salary of a data analyst. Once we have done that, we can set the plot size. That's the size of the plot. We want to ensure that this particular plot has particular size. Sometimes if you don't set this, you might get a smaller visualization by default. So it's important to do that. And we set it using the PLT. PLT actually references the Matplotlib pyplot submodule that we imported. So we will use PLT .figure. Figure, this is a function that allows us to be able to set the plot size, and we use the argument fig size and we equate it to 6,5. What you see here is, as it's a tuple. In Python, that's a data structure that you cannot be able to change later, but we set it to 6,5, and by 6,5 we mean six dimensions and 5 units. That may vary with how you want. So normally you just play around with these particular figures to be able to just get the desired output. Maybe initially you'd use 6,5 and you realize the visualization's a bit smaller, then you could change and create and change the numbers, maybe change them a bit, maybe 8,5, 8,6, depending on your use case. So once we have done that, we move on to the next thing. We render our plot. Now we use the plot function, and inside the plot function, we define the first. Now the function itself, each function. So when we are working with Matplotlib, there are different functions that we can use to generate different types of visualizations. Like for example, if we want to plot a line chart, we can be able to do that by simply a line graph. We can be able to do that using a plot function, and inside that plot function, inside the parentheses, we can decide to we actually set the arguments that are appropriate for that function. So for this plot function, which creates a line graph, we set the age. We set one of the axis to have age and the other one to be salary. So this could be X and Y. Then we also set another argument. By argument, it's just generally like a property of the function. So it's like an attribute, like a characteristic of that function. So we set the X axis and Y axis. Then we set the color to be blue, comma, the label of that particular plot that we are creating. The label is just going to be shown in our legend. If we have a legend, which we do have, we do set it here, we should be able to see DA salary in that legend. The next thing we do, we give a title to the chart. So plt.title. So we also inside the title function, we set two parameters, two arguments. So we have age versus salary, which is the title of the chart, and then we set the font. We set the font as well as just styles of how we want to have the title look like. So font dict equals, this is a dictionary that has the font name as serif, font size is 10. This would you would normally check this in the documentation that will be provided in pandas, but you could not in pandas but in Matplotlib, but you could always just search online but by just clicking Matplotlib documentation, and you can find just more information about that particular bit in your that particular you can find more information about those parameters there. The next thing, we set the X labels. Now the X axis would need to have a label. With every data visualization practice, best practice, we need to have a label for X axis. So we use the X label function and we set it to employee age, That's the first argument that we set that as employee age, which you could also actually provide more. You could actually define how it looks by going through here. And once we have done that, we also set the y-axis label by using the y-label function and set it as salary. That's what we want to display. And you could again use the, you could also set these styles using this approach as well. And then we add a legend. We had already had a label that we wanted to display. Then we show the plot. We need to show the plot in order to visualize the plot in our notebook. So run that and you should be able to see the plot, which is here. And you can see legend. Our legend is DA salary, which we used a label for that as well. X label, it's employee age. Y label salary. Title, it's what you see here, but the font we've set out a font that we want. And on the x-axis we have age, and on the y-axis we have DA salary. So that's one approach. It's usually a straightforward. Just understand that you need to use the plot function for that. But each and every visualization will come with its own function that you can be able to use to visualize the data that you're working with. All right, moving on. So by the way, when you drag your mouse on top of the functions, when you're doing that on Google Colab, in this notebook, you can drag your mouse on top maybe of a function that you're not sure about. Maybe you want to get more information about maybe X label and figure out what arguments to set. If you drag your mouse, you will see a window that pops up, and it provides just information about that particular function, which DX label, it has these, you can actually pass these parameters that you see. Drag my mouse and again, and you can be able to see the kind of information that each and every label can, each and every the kind of arguments which are under parameters section that you can be able to set for those particular the function that you're working with. All right, so here we had only just we had age and salary. So sometimes you might also have we might want to compare maybe the A salary with the S salary. So maybe have 3 or 4 different kinds of salaries for different groups. But this is data analyst, might also provide maybe data scientist or software engineering salary and provide the data so that we can compare it with this. So to do that, what we are going to do, we're going to add just another list that contains the same number of items. So in our situation, we might want to have maybe data scientist salary, DS salary, equal to this particular list, which will contain just numbers, or just numerical figures about data analyst salaries. We set the plot size, and then again, we're going to, this approach just refers to just now deciding to have both in one plot. So we can use the first plot and do the same case here, the second plot. So we plot age versus DA salary, age versus DS salary. We set the colors to be different and the labels to be different. We set the title, X label, Y label, legend, and show. If I run this, I should be able to see that we have now 2 different line graphs, which we can see some comparison between the two. We can see age as well as salary for both particular groups of roles. We have data science salaries a bit higher than data scientist salaries. Now, to be able to plot different kinds of visualization. So in our case over here, we had a line graph. We use the plot function. But if we want to use something, we want to plot maybe a pie chart, which we'll come to, you'll see we have a pie function. For bar plot, we have a bar function, histogram function, scatter function, then box plot function. Just for helping you to just see where we are going, and inside the different functions, we have different sorts of arguments, but these are the default ones. Like you need to have two different pieces of information for the plot function, like we did here. Initially we needed, this is a must to have in this, but when you're using this particular function, so you need to have two pieces of information, so x and y. For pie chart, you just need to give some data set, just one particular piece of information. Same case with bar plot, same case with histogram. For scatter, you need two, and for box plot, you need one. So let's now go through the second method. So this is the first method where you have a plot and you also can be able to add more plots. The second method is a bit more different from the first method. So just to help us understand this method, you can think of a visualization as more of what is described in this image. So a visualization has different components when it comes to Matplotlib. So this is the second approach. The first component is what is called a figure, and it can be, you can think about this mentally, and this is the outermost container or component. Let's just call it a container, or maybe a component. Yeah, this is the outermost component, figure. Then inside the figure you have an axis. So inside the figure you have an axis, and you can have multiple axes. You can have two axes, or 3 or 4 or 5 axes inside a figure. So normally in Python, these are called a figure object, and there's also an axis object. So a figure object contains an axis object. So when it comes to Python, using this approach, you would normally consider, first of all, defining a figure object as well as an axis object if you're working with just one particular visualization. Or if you want to have one chart, you could just have one figure and you have one chart inside that figure. But in some other cases, you might have one figure and have multiple charts. So that is also something that might come in handy. So a figure, multiple axes, one axis. So inside each axis, you have different components. You have an x-axis, y-axis, as well as some other components that would go inside, like, maybe a title, you could have labels, etc., and even a plot, etc. But the idea here is that you have one figure. Sometimes if you want to create just a visualization, just one visualization, you can have just a figure and an axis, and that's basically it. So you can have a look at that, try and understand what's happening, but that's the second approach that we're going to be using. So again, using the method that we were using. So we first of all define the data set that we want to use. We're actually going to do the same task that we did here initially, like what we did here. But now we're using this second method. We're still going to use the same data set. Actually, we will start from the example, just implement the same, but now using the second method. So age and DA salary, we define the data sets, and then we now define the figure and axis objects as shown. So we have these particular objects, as you can see, so this figure and AX. And we do that by simply using the PLT by referencing Matplotlib using plt.subplots to be able to create a plot within our notebook. So once we have done that, we use AX which is the axis object, to define what plot that we want for the actual visualization that we want. So we render the plot, which is in our situation, remember plot function would actually create a line chart or line graph. So inside the plot function, we have age and DA salary, still like the same as before, color as well as the label, and then we show. Here you have a bit of some different bits. So because here we were using plt.show, but now in our situation we're here using the second method, we have fig.show, which should be able to display our visualization, just similar to what we had before. You can even compare that with the first method that we had. So this actually uses less lines of code. Well, does it? No, actually it doesn't. Actually this does. I think it does. We can do that. Let's now maybe add the DS salary. So we wanted to have two different lines within this chart. Well, how can we do that? We're still going to use the figure and axis object that we created. So we reference, when it comes to creating a second plot inside our a second plot in not yes a second plot inside our axis, we just are going to define the second the second um, the second plot, and we're going to use the second data set as shown. So we first of all define the first data set and how we define the first plot and how we want that to be plotted or to be built. Age, DA salary, we define the label as well, and then we also do the same case for DA salary. And then we can actually add our titles, x-axis label, y-axis label, adding a legend, and also a grid, like the lines behind, as well as show using the axis plot, the axis object. So instead of referencing plt.plot, we can just use the ax, and we can actually use the axis object that we defined earlier, as you can see here. So that's what we do, and let's run this, and we should be able to see both of them. And we also have a grid. And again, if you want to customize the grid, how it looks, you can just drag your mouse and be able to see on top of grid and be able to see the kinds of arguments and parameter, the kinds of arguments that you can be able to include, and you can play around with them or even have a look at the documentation for that. All right, so that's just generally it for how to work with the second method. But again, this was actually, yes, I see what's happening here. So this we did for only one chart. But what if we wanted to create another chart on the right hand side and visualize maybe DA salary on its chart and DS salary on its chart? So we can decide to create a second axis object, as you can see here. So we start off by creating, again, defining the data DS salary list as we did before. That's the data set that we will work with. Then AX2 PLT subplots, and inside this we can be able to define the size of our plots as well as the number of plots. So this just defines one row and two plots. So we want one row and we'll have two plots, and we define the figure size or the size of both plots here that we want. Then we say ax1.plt age DA salary. That's the first plot that's the first plot that will go in our axis object, the first one. And in our second axis object, we want DS salary to do the same. And we add a title for individual for each and every axis. So the respective axis also do the same for x-axis, y-axis, the legend, grid, as well as display the plot. And we can see that here you can see employee salary. For this is for DA, this is for DS. As you can see, even the legends themselves have it. And that's basically it. Once you have understood those two methods, you just realize just working with different plots using Matplotlib will actually be quite easy. So just play around with that. You can pause the video, just play around with just the different concepts that we've talked about. We will be reusing them in the next few sections. All right, moving on to the next section. So once we have gone through that, we can now go through each and every section. So pie chart, how can we be able to work with a pie chart? How can we build a pie chart using Matplotlib? So we'll have two examples. The first example, we'll just use some dummy data sets that we have created. The second one, we'll use some data sets that we'll import that will contain quite a number. It will actually look real life. So it will contain quite a number of records. So starting off, example one, pie chart. So a pie chart generally would be a visualization that would allow us to show proportions or percentages between categories by dividing a circle into proportional segments. So starting off, we first of all prepare our data. So in a pie chart, we would need to prepare different kinds of data. So in our use case for now, we're going to have the quantity, which would just be so, you know, by the way, the question that we have at hand is create a pie chart that describes fruits quantity in a basket. So the first thing that we do is define the quantity data using the list as shown. So quantity is equals to that, And then we define, this is going to be how we are going to label each and every section. So for 35, what does that mean? Coconuts. What does that mean? Like 35 corresponds to bananas, 25 corresponds to coconuts, 25 corresponds to grapes, 15 corresponds to apples. So we define also the labels and also the colors as shown here. And again, the colors also correspond to the different pieces of information here, like 15 with this particular color. And for color, we can use just the normal colors that we know, but again, there's usually specific. You may not be able to just input any color here. You'd also need to ensure that it's a well-defined color by simply going online and searching on the colors that work with Matplotlib, or alternatively, you can use what is called a hex code, which this is how we can also be able to define the color that we want using just code. Hex codes are quite popular, so if you want, you can always just go to I think if you go to Google and say hex code, you should be able to get some tools that allow you to just be able to retrieve a hex code of any color that you want. Let's say, for example, that first one, I can see the hex code is this, and I can copy this and be able to paste it inside where I want. Or I can even just play around with the colors. I try and figure out the color that I want. Maybe I want this grayish color almost. Then I copy this hex code and use it here. So this is usually just an easier way of just being able to define how you want the colors to look like. But the most important piece of information is quantity, and that should give you just some good visualization. And we had seen before, pi just requires just one piece of information. We had seen here, is it here? Pi just requires one piece of information. The Z here just represents the data set. X and Y, also, these are two different data sets. Okay, so where are we? So here we are. So we prepare the data that we want, and then later onwards, we render our chart. We're going to use this approach for prepare, render, tweak, and label, and then display. So once we have prepared our data set, we can set the size of our visualization. Now here we are using the first method that we learned earlier to just create a pie chart. Then plt.py, this is the pie function. We set quantity as the data that we want to use for the creation of our pie chart. Then we set labels as a second argument and set it as fruits, this particular piece of information. Colors is this colors list that we had here. And then we set how we want to display the different proportions, because it would be in percentages. So we want to round off to the nearest whole number. That's how we do that. And explode over here, which is another argument. This just tells us to be able to segment certain pieces, or to highlight certain aspects or certain sections within our pie chart. So from here, you see this is 0, 0 0.1, 0, 0. And the number of items, this is a tuple. Tuple usually is enclosed in parentheses, the data structure in Python. And you can see these are 4 items within this tuple, and they correspond to the number of items in quantity. So for 0, this corresponds to this. So for 0.1, we actually, this corresponds to this. And we're actually trying to highlight this coconuts bit as a point of focus when we want to display this chart. So we say 0.1, and you can experiment with this. You change this to 0.2, 0.3, but generally just do it not so far. But you'll see what we will mean. And 0 to just mean that we don't want to explode. We don't want to take away a piece of the pie chart away from the actual pie. Then here we set the title of our chart, and we show it. So running this should give what we have here. And you can see 0.1, which corresponds to coconut, is what we have here. So 0.1 is a 25%, and 25%. If you don't have this, if you don't put a 0, if we do this, let's do this. I don't know whether we'll get an error for that. No, but we won't. If we haven't defined auto PCT, we will get these numbers. That's why we define that we want to have a whole number as shown. All right, moving on to the next example. Now, this example, we just used some data set that we had defined, but what if we had a data set that we wanted to display the distribution of just the pieces of data set that we have? So the first thing that we can do is, first of all, import our data set, which we import here. And this data set, if I create a new cell over here and paste that and display that, I've imported it, df.head, we can learn this in the data wrangling course that we have as well. So run that. And you see this is how the table looks. So we want to create a pie chart that will describe the distribution of Olympic gold medals. So that's what we want. So we import that data. That's the data set that we want. So any sort of table that you want to use to create a pie chart for needs to look more like this, where you have some labels on the left hand side, and also and also the numerical related information on the right, which is just generally a summary of the bigger data set. So we import that data. We then reference we also store now the labels, which is what we're going to have for the different sections of our pie chart. The labels are apples, grapes, coconuts, bananas. So that information for country, for this data set, will be on from the country column, which is here. We store that in countries. The same case for the numerical data that we are going to use for this particular case. DF will come from the DF gold medal. We store that there. Explode. So instead of defining our 2 inside here, we can define it outside in a variable and just pass the variable here, like what we did with colors and fruits. So that's what we do here. We explode. We define 1, 2, 3, 4, 5. These are 5 different pieces of information that we have. So that will be actually referencing the 5 different labels that we have, or categories that we want to display the distribution in a pie chart. So once we prepared our data, we can render. We set the size of our chart, and then we use the pie function. Gold medals, we reference gold medals. Labels, we set it to countries. Explode to this particular variable, explode. We might also want to tilt our pie chart. Rather than have coconuts appear here, we might want it to appear on this other side. So we can do that by using start angle, and we can define it the way we want. Auto PCT just sets the values to just whole numbers. Then we add a title to the chart, and then we display it. And there you have it. This is our pie chart that we can be able to use. In some situations, if you want even to save, you can just highlight, copy, and save image assets, etc. But there's also a way of just exporting it using Matplotlib. So we are done there. We're done with that. Just work on the challenges, and once you have gone through the challenge, you can go through. Once you have gone through the challenges, both challenges, which you can use the examples that we've provided to learn from, go through the solution notebook that we have provided there. All right, so moving on, by the solution notebook, by that I mean just being able to verify the solutions that you have. All right, moving on to the next concept, bar charts. So we normally create bar charts in order to present some categorical data with rectangular bars. So if you want some heights as well as length proportional to the values that they represent, then we can use a bar chart. So starting off, we are going to go through this question. So create a vertical and horizontal bar chart that describes the distribution of cake sales for bakery. So this is the piece of information that we have. We have cakes data, and also we have, yes, cakes data and sales data. Okay. All right. So we prepare the data, and then we render our vertical chart. So normally by default, when you use the bar function, we can be able to create a vertical bar chart. Then later, so inside the bar chart, we have different arguments. We have cakes, which will just act as our labels, and then height of the vertical bar charts, we can set that as sales, and then color, the color that we want. This you could also set it to have just the hex code that you want as well. We do that, we render the vertical bar chart, and then we set our xticks. Could be just the the actual bars within the visualization that we want. We set the Y label, title, and then we display. And you will see that we have this, as you can see. By xticks, we just mean the rotation of the labels, the X labels for each and every bar. So that is what we do here. And that's it for that. But now, what if we wanted to have this is a vertical bar chart, but what if we wanted to have a horizontal, ones that move from left to right? Instead of using bar, we can set to bar h. So you can see here bar h, and the same information, the arguments will just remain the same inside, and just do the same here for xy labels, x6 title. And we do that, and we should be able to see our visualization as you can see. All right, so work on the challenges for the bar, no, not even bar charts. Actually, there's no, yes, okay, we haven't gone through the second example. Let's go through the second example. So assuming we had this data set, which we can be able to prepare, let's just see how it looks. This is how the data set looks. We have just different, there's a total bill. So these are just bills by customers for could be a restaurant. So this is gender, tip, total bill, smoker, that person a smoker, was that day was a Sunday, time, they came in dinner time, they ordered for 2 persons. So so yeah, so 2 servings or 2 persons could be that. So generally, we can do the same thing, like create a bar chart. So we'll start off with, first of all, by preparing our data set. We have seen how it looks. We can create a summary table. We need a summary table for this particular use case. So we need a summary table that summarizes. We have on the very left day, could be Sunday, Monday, Tuesday, Wednesday, Thursday, and on the right, bill, so that we have which particular, like by bill could be some, so that we have the distribution of how much was spent by customers for each and every day, and we know which are the peak days, or which are the days where customers spent the most. Like you can see Sunday, actually Saturday, it's when the total bill was a whole lot high. So this is our summary table that we have. We use the group by function for that. Specify day to be on the left side. So this particular concept, we cover it in the data analysis with Python workshop. So feel free to go through that workshop as you need to. And we set as index as false to be able to get the data frame or the table that we are working with here. And we use NumPy for summing the information, the total bill information. So we end up having this. We haven't yet finished preparing our data. So for summary total, so we store days, the labels in the labels, all these labels, Friday, Saturday, Sunday, Thursday, inside days using this particular way, which is just referencing the data frame here that we have and the column for that. The same case, total bill. We also do the same thing here. Then we use our bar chart. This is our horizontal, the vertical bar chart. We set the days. Just again, as the first example, you can just remember the first example. Set height and color, and we tweak the visualization and display it. And there you have it. Work on the challenges, and once you have worked on the challenges, you can just check on the solution, on your solution through the use of the solution notebook, and then we can continue from there. All right, so moving on to the next concept, histograms. So we normally use histograms when we want to visualize the distribution of data over one particular variable or one column that we have, which is continuous or has just multiple points. And we can do that using a histogram. So let's learn how to work with them when it comes to Matplotlib. So our question will be, create a graph that shows the frequency distribution of the following data set. So we can first of all set our data. So the height data, this is the data set that we have, and we also have bins. The bins would be how many of those. Bins are usually critical when it comes to working with histograms, and you normally have bins. So you would use this to show the frequency distribution within your histogram. Then once we do that, once we have these two key pieces of information, we then use the hist function for setting the um, the height as well as the bins information. So the data that we want to visualize the distribution for is the height. Then we set bins to equal to bins. But bins may not necessarily be a required um, argument in our case, but we just set it so that we're able to visualize what we really want, the distribution across a certain range that we want. Then we do the same, like tweak and label our plot and then display it. And we do that, and you can see what we have, and we can see our distribution, which is skewed to the left or right, skewed to the right. All right, so the second method that we can do, the second method that we can be able to actually, this is the first method. We just defined our data set, but we can now decide to use an existing data set. So let's just load the data set that we're going to work with. And to answer this question, which involves create a histogram to display the frequency distribution of the overall variable in the FIFA dataset. This is how we can be able to see the dataset. Okay, this is how we've loaded the dataset, and we can see just some more information about those particular. The dataset just contains information about different players. And once we have done that, we can, once we have loaded our datasets inside FIFA DF, we want to work with the overall variable. So overall variable looks like, where is it? Overall, this variable, it's a rating in football. So overall variable, this is what we want, and we set the bins that we would want to use. So we use the histogram function for the same, and we set overall and bins, and then we tweak and label and show our plot. And you can see our histogram. So it tells us quite a number of the players in the data set actually have the skill level, which is actually the overall rating, overall variable, which actually defines that, in between 65 and 70. 70, yeah, 65 and 70, because that's the highest bin. So almost 5,000 or so users of also players. All right, work on the challenges, and then once you've done that, verify those solutions, your solution with the solution notebook. Moving on, the next section that we'll go through is line graphs, and we normally use them to display quantitative values over a continuous interval or time period. And just with the goal of just identifying whether there's certain trends within the data that we are working with, or even just understanding the patterns of the variable that we have in question. So again, using our previous approach, we first of all use just a dummy data set, a data set that we create, which has, and we set months as well as sales as the data sets that we'll use. On the x-axis, we want months. On the y-axis, we want sales. We use the plot function for that, set, and we tweak and label our visualization and display it. And you can see sales and then months. Let's use a real life data set. Create a line graph to describe the trend of gas price in the UK, USA, and France since 1990. Let's visualize this data set. Okay, so we want to visualize the year, then UK, USA, and France. Okay, all right, so let's do that. Years, so years, we get the years column and we set it to list, which will return the list values. UK prices, US prices, France prices as well. And then we render, we display our chart. We do that for individual, want 3 different line charts. So we want 3 different plots. So we have UK, USA, and France be lines. We'll compare that against years. And then we can see that. We can just tweak and label and display that. And you can see how those gas prices were. For France, they were a bit higher per dollars for a short period of time before for the UK actually surpassed the prices for France, and they've been alternating since 2008. Actually got the same, almost the same. Actually, France was slightly higher for that. And you can see that we can also be able to define the markers inside our plots. Let's say markers to be 0 or dots, and we do that by defining O. It's actually an O, not a 0. All right, work on the challenges and then verify your solutions using the solution notebook we've provided. Okay, moving on to scatter plots. When we want to determine if there's a relationship between 2 variables or 2 different columns that we are working with, then we normally use scatter plots. So we would normally want to just identify just two variables, and then we use a scatter plot. So to identify the relationship between those 2 variables or data sets. So in our situation here, we have a question that asks us, create a scatter plot to describe the relationship between 2 variables. So one variable X will have the following data, and another one will have this other data. And then we use the scatter function. So on the X bit, we set X and Y by plt.scatter. We label our axis as well as have a title and display it. So this is what we get, a scatter plot. So how to interpret scatter plots? Normally when you have points moving from one particular point horizontally, but now in a diagonal way, like as you can see here. Normally in our situation, we interpret that as there having been some relationship between the 2 variables. So we have we have Y variable and X variable. So in our situation here, we have the Y, we have a positive correlation, like as values of X increase, also values of Y increase. In some other situations, you might realize the points in the scatter plot are everywhere. In such a situation, the relationship is usually quite low. Sometimes we just say it's not correlated, but we usually to be more specific, we just say there's a weak correlation between the 2 variables. And sometimes this line can come from this other side, can be this other side from this corner towards this other corner. That would still mean that those 2 variables are correlated, because as values of Y decrease, also the X ones also would increase, but there would still be some noticeable change over with the other variable. So in such a situation, you'd have a negative correlation. So that is how you interpret a scatter chart or scatter plot for that matter. To work with this, to work with a scatter plot for a real life data set, let's go through the second example. So create a scatter plot to determine whether the population and income variables are highly correlated. So here we have a data set. Okay, we don't need that. So if I run that, should be able to see our data set. We have country, assuming that I think we have also have our countries, and life expectancy, income, say year, population, continent. So we want to determine whether population and income variables are correlated or highly correlated. So we prepare our data, we store the population data inside population variable, income data inside the income variable. Then we render a scatter plot using scatter function, population, then income. We tweak and label our visualization and display it. So you can see here, we don't have points running, across diagonally. So in our situation over here, there's no correlation, a high correlation. So these two variables are not highly correlated. So it means that it does not necessarily mean that as population increases, the income is also high. Or as income increases, the population is also high. So those two variables don't have any correlation at all. Because some people might argue that, you would expect that when you have a big population, the income is also high, which isn't the case for a country. Okay, all right, work on the challenges and verify your solutions with the solution notebook we've provided. All right, lastly, we're going to go through a box plot, and this type of visualization allows us to be able to to understand whether there are outliers within a data set. It also does give us an idea of a distribution of data within a variable. So let's first of all set some data that we're going to work with. So this question, plot a box plot using given height data set. So this is our data, and we might want to determine whether there are outliers within this data. So outliers would be those points that will be far away from the most points. And mathematically, in our use case, when we're using box plots, we normally use what is called an interquartile range, where the box plot would help us define how spread the points are, and a majority of the points would be in the 50th percentile. So if you were to put all those points within a scale, a majority of points would need to be between 25 and 25% and 75. If you have points within that particular range, then those are just normal points. But if you have outside that particular range, then we can treat those points as outliers. So first of all, we define our height, and then we use a box plot function to be able to plot our box plot. We set aside the height. We set the height data as shown. We do not necessarily need labels. That may not be the same. It's not necessary. We display. We actually set in our title as well as a white label, and also show the visualization. So if I show you our box plot, this is what we get. A majority of the points are between this particular box, actually defined by this particular box. So you have most points being here. So around 91 or 92 and 110. But you have these 2 points over here, which are far away. So in our situation, there are outliers within this data set, which are quite far. So that's how you can be able to create a box plot, but you can create actually multiple of them. That's just one. In our situation, we might also want to apply this in a real-life data set. So create a box plot to determine whether beer servings and spirit servings contain outliers. So let's run this data set, run this code cell to be able to see our data set. So country, beer servings, as well as spirit servings. So want to see whether there are outliers within these two particular columns. This is how we do that. We just prepare our data set by storing the respective data in the respective variables. Then we use box plot. Then we define a tuple for the data that we want to compare. Then we set the labels, and then tweak a label just to set the title and display the visualization plot. And there you have it. We can see in beer servings we don't have outliers, but the data is far much more distributed than in spirit servings, because by distributed, how spread means how spread the data is. So it's much more spread in beer servings than in spirit servings. It means that there are more, the in our situation over here, the which, beer servings here just means quantity of servings. So much more quantity, there were much more beer quantity servings in this case than in this particular case. And we're only working with one particular, we're actually working with a total of all the countries, not just one particular um, country. You could decide to perform that analysis by simply narrowing down to just a few countries and being able to do that. But for understanding, we see that um, we actually apply everything. We actually apply that to the entire data set. But here you can see the outliers for spirit servings, the number of servings. And that's generally it. All right, work on the challenges and then verify your solution and then come back. All right, so once we have finished working on our practice notebook and having gone through the solution notebook that gives us challenges to go through, that gives us solutions, potential solutions to our challenges, we should now be in a good position to be able to now go through a project that will just give us an idea of how we can be able to apply the skills that we have learned in a real life case scenario. So this is a project that we have provided. It has a data set. The idea is for you to go through this project. Once you have gone through that project, um, you will need to look at the sample solution that we have here. But in an effort to ensure that you're able to go through the project easily, we've also provided some sample solution, which you can see here, that should give you a good idea of how you can be able to go through it through the project. Now, the project solution that you'll find here might be different from what you would want. So don't worry so much about it. There are many ways that you could approach a project, and this is one of the many ways. So feel free to use this approach when it comes to any approach that you think would be much more important. And you can also learn generally from what we have shared in this particular data set, in this particular solution notebook. And generally, that's generally it when it comes to data visualization with a Matplotlib. The idea for you was to have achieved these learning outcomes that we had initially set out to work towards. Be able to recall and describe the fundamental types of plots when it comes to working with Matplotlib, apply those apply Matplotlib concepts to be able to explain and analyze data sets visually using just different types of plots, and lastly be able to analyze complex data by creating multi-panel figures and subplots using Matplotlib. So the next step I would highly advise for you once you've gone through this course is to go now through another course called Data Visualization with Seaborn. That will just be an advanced step from this particular workshop. And then once you have finished that with Seaborn, you can explore other data visualization libraries such as Plotly and Dash and even Bokeh. And that should also give you a good idea of, it should ensure that you are actually good to undertake any sort of data analysis project or working on any sort of visualization deliverable when it comes to Python. So all the best in your journey and see you in the next course.